Perth Linux Users Group, talking Linux and open source.
As you may know, I've started working for Amazon Web Services for about 5 months now, based here in the Perth office for Amazon Web Services. Most of you, I assume, here I've probably spoken to in the room, have heard of Amazon at some stage. In fact, probably, who here has not bought something from Amazon over the last sort of 17 years or so? You've never bought anything from Amazon? Yeah, of course you have. I know, Hannah, you survived on Amazon living in London, as did I. But anyway, so same company. Let's kick into this and hope the clicker works. Yay, who is Amazon? So I'm going to go through basically an overview of what AWS is and then talk about some of the newer stuff that has happened that you may have missed. Specifically, the big one is that Amazon opened in Australia 4 weeks ago today. So AWS, that's one of the fulfillment centers that Amazon uses for delivery of the retail site of Amazon Web Services. There's a whole bunch of these across the US and Europe, as we know. Same company. Effectively, there's 3 parts to Amazon's business. The original sort of website that was set up in mid-90s or so, which is now 17 years old, is the consumer business, online retail, traditional retail. That developed into a platform for sellers to be able to go to the website, list their merchandise and sell through them. And at the same time, the technology part of the business was reinventing itself to provision compute and storage in a more efficient way for the rest of the business. And that came out of being sort of only internal to Amazon, obviously at quite a significant size, to offering its first public offering in 2006 and was branded as Amazon Web Services. So it's now been going for some 6 years. So first public offering was March 2006 from the company, as I said. And it was message queues as a service, not the most obvious thing for AWS to be offering. It wasn't the famous S3 or EC2 that everybody's aware of, but SQS was the first thing that came out. EC2 was second, came out in August of that year as a beta and went GA in October of 2008. And AWS now has customers in 190 countries, so it's pretty global. The main things about what AWS is talking about with cloud computing. So I guess everyone in this room has heard of cloud computing. It's kind of, yes. Indeed. There's more to that. But let's go on to this. The tenets of what Amazon thinks is cloud computing. These are the key things behind it. It's got to have 0 capital expense. Nothing to get started, no upfront commitment or no upfront payments that you need to get into. You should only be paying for exactly what you use. You shouldn't be having to buy larger servers and then not be using 100% of that capacity. You should have the ability to be elastic on demand. So add servers, remove servers, without having to pre-arrange or pre-authorize that. You just add them, turn them on, turn them off. It should be a fast time to market so that you don't have to set up contracts or anything like that. Just get into it. The differentiators between Amazon, as I said, we don't do contracts or obligations or long-term commitments. In fact, the longest term commitment you can do is basically about an hour. Use a server for an hour, turn it off, that's about it. We're constantly innovating the platform to try and improve it and make it better for people. And we keep lowering the price. So in the 6 years the business has been operating, we've dropped the price 24 times of various bits of the services and haven't put the price up at all, and that's in the face of no real competitive pressure. So Amazon as an online retailer has basically been high volume, low margin for 17 years, and that kind of pedigree has come through in Amazon Web Services that we continue to be high volume, low margin. And that's actually why you see different prices for Amazon depending on where on the world you want to start your storage or store your stuff or start your compute. If it's more expensive for us, that gets past the customer. If it's cheaper for us, that goes straight through to the customer as well. So the US is generally cheaper for data centers and power and stuff like that. Tokyo, South America, more expensive, and that's transparent in all the pricing. And it's up to the customer to choose where they want to put into their storage or compute. Right, our focus is security. So AWS actually spends a lot of time looking at security to try and ensure that the public cloud, the AWS cloud, is secure as possible. And it's something that I've actually spent a lot of time on, looking into all of the certifications of what they cover, how often they're done, and understanding the requirements of different industries with regards to those certifications. We do operate what we call a shared security model. So AWS, as a cloud provider, is responsible for all of the physical infrastructure. But that division between us and the customer stops at the hypervisor. And so our customers are fully capable of configuring firewalls and either keeping things private, which they are by default, or opening up as they need to. So that's a fully shared environment for that. And as it says, all of our endpoints that you'll be talking to as a web service, which Amazon Web Services is, are fully encrypted. You're using SSL, all with certificates which are valid across all of them. So our security is pretty tight. Our focus is also our customers. We actually take most of our innovations from requests from what customers would like, versus what other people might be doing in the space. So if you've got something that's giving you pain as a customer of AWS, talk to us, and we'll find out if other people have been having similar problems, if they've got common solutions to it, or if there's something that we can go and turn into a service. And so some of that's classic stuff like managed databases, which installing an EC2 instance and then installing your favorite database server and running it and backing it up and doing replication to another data center. It's pretty commonplace, and we've turned that into a service called Relational Database Service, RDS. So it's worth talking about where we are, because we talked about global stuff. The terminology that AWS uses is as follows. A region is a location where customers can store their data or bring up compute instances to do their workloads. And we've currently got 9 of those worldwide, of which 1 we're not allowed to use because it's reserved for the US government. That's called GovCloud. And the other 8 are available for all of our customers to use at no notice at all. You can swipe a credit card, get an account set up, and bring up compute immediately. Inside each of those regions, we have the concept of availability zones, which you can think of as being a cluster of data centers. So we always launch a region with at least 2 availability zones. That's 2 clusters of data centers, so that when you're designing and deploying your application, you can deploy compute to both availability zones, put a load balancer in front of it, and you've got the very starting of an HA architecture. Beyond availability zones, we then have edge locations. An edge location is basically an outpost where we've got some compute, but not for that customers configure. It's used as a location for our content delivery network and our hosted DNS service called Route 53. So those 2 products work from our edge locations. So there's a map of the world that's out of date. I thought I had updated that. It was like that. Except what we did, in fact, I should have updated this last night. I'm sorry, I forgot. The big news that we did was 4 weeks ago we opened an availability region in Sydney with 2 availability zones, and that was announced and is ready to go, and people have been using that successfully ever since. You can see, other than that, Singapore is our next closest location from here, and Singapore and Sydney are roughly the same distance apart from here. Tokyo, Ireland, Sao Paulo in South America, and then across the US. So availability zones, as I said, we have a region which breaks down to a number of availability zones, and there's always at least 2 availability zones. And sometimes we'll add an additional availability zone, or we'll grow the additional availability zones based on demand and availability of space. And as I said, that's a cluster of buildings or facilities. Each AZ operates independently from every other one. So the A and B availability zones are connected by low latency connections, so single-digit milliseconds. Close enough that you'd be able to do synchronous writes to the 2 AZs without really having a huge penalty on waiting for that. Whereas if you were doing sort of East Coast, West Coast US, or East Coast, West Coast Australia even, the round trip time would be too high for doing synchronous writes, potentially. They're geographically separated, even though they're quite close together as far as latency goes. They're far enough apart for different floodplanes, different power, different network connections, etc., etc. The kind of things that you'd want to design for yourself. And those high-speed, low-latency connections. So our edge locations laid over the top. There's 38 of them now live. About this time last year, it was probably around 24, 25. So there's an aggressive rollout of additional locations. And obviously, that's going to continue into the future. Quick overview of some of the base services. SQS. Anyone here used a message queue before? Yeah? Any message queues. Familiar with the basic concept? Yeah, most of the people. So you put a message and you read a message from another machine. Messages on SQS can be up to about 9K in size. You structure its text, you put whatever you want in there. I'd always look towards either XML or JSON, probably JSON these days for a long while now actually. But it can be anything you want. Storage we have effectively 3 solutions for. So S3, the simple storage service is probably the most well-known of that. It's an object store where you put an object, a file, and you get an object. And that's about the sum total of how simple it is. There's over 1 trillion objects now sitting in S3, and it currently handles request rates of around 835,000 requests a second, I believe it is. So it's pretty high volume during the peak of the day. And as far as we know, it's the largest object store that's around. Beyond S3, we have EBS, the Elastic Block Store. That's provisioning storage for virtual machines between 1 gig and currently 1 terabyte that you'd attach to a machine either as its root volume under Linux or a C drive under Windows, or additional volumes should you want additional volumes for any purpose whatsoever. And then you can do things like stripe them and RAID them or whatever else you want to, if you so wanted to. Otherwise, put a file system on them and go for it. You can snapshot the EBS volumes if you want. So if you've had a separate data drive for your application, you can snapshot that, and it puts that snapshot into S3. And then lastly, the new one on there for this year is Glacier, which is our cold storage or archive solution, which came out about 3 months ago now, I'd say. Anyone heard of Glacier? Yeah, it kind of made a bit of the news when it came out, because I don't think anyone was expecting it. But effectively, think of Glacier kind of like S3. It's got the same kind of level of durability of data, of guarantee that you're going to have that data sitting there. Except instead of coming in at the pricing, for example, right now, the Sydney pricing, which was dropped last week, is now 10.5 cents per gig per month in Sydney. Glacier starts its pricing from 1 cent per gig per month. So it's an order of magnitude cheaper. You can do all of your transfers online. You can do transfers via Direct Connect Fiber if you want to do, or you can do it via hard drives in the post. But once the data's there, it sits in Glacier until potentially you'll need it back. If you want it back from Glacier, the retrieval time is between 3 and 5 hours. So the trade-off you're getting is your data is slower to access, but it's 10 times cheaper. And so for true archive, it's a great solution to just throw data that you probably won't need for a long time. And EC2 is the last one on there, which is the Elastic Compute Cloud. Virtual servers of specific sizes, we call them instance types. And an instance type has a certain amount of CPU power and memory associated with it. And there's currently, I think, 14 instance types available, from the micro, which is our smallest little baby one, right through to something with 68 gig of RAM and God knows how much CPU available. All of this is actually documented online, showing you a comparative compute availability to each of these instance types. So SQS, as I said, throw a message in it. Message can stay there up to 14 days. Read a message from it. There's a whole security matrix which goes over the top of this so that you can actually provision certain users that have got access to create a queue or write to a queue or read to a queue. It's quite simple. Sorry, 64K, not 9K. I don't know where I was getting 9K from. And you receive a message from an endpoint. And you can share data between users on AWS just by provisioning access through the security interface. So it's a nice way of being able to fan out jobs to other people as well. Storage. S3 Online, as I said, EBS for volumes, and Glacier, our cold storage for archive. S3 has the concept of a bucket. Basically, you can think of it as a drive or a volume. You put objects into the bucket. You create as many buckets as you want, and it's a convenient way of organizing some of your stuff. There's no upper limit to how many objects you can put into a bucket. It doesn't have a full. We just keep buying disk, and it just keeps growing, which is why we think it's now the world's largest object store. Objects individually can be up to, I think it's 5 terabytes in size. Whereas on Glacier, that can be up to 40 terabytes, just by comparison. But you know, you can put massive things in there, you can put 0-byte things in there. Yep, there we go. You define the path for it, and you can put as many as you want in there. Getting the object, well, privately you can do that with authentication. Publicly, you can do it as a download. You can also do it over BitTorrent. So if you've got something that you wanted to serve over the BitTorrent network, one of the places you could put that for a seed server is actually in S3, and then just reference the URL, !BitTorrent equals 1 or something similar, and it will shard it out into the BitTorrent peer-to-peer network, which I kind of liked when I read that. I was tickled my fancy. Or you can actually use the content delivery network called CloudFront, which will effectively amplify out your distribution to all of those 38 locations which are currently live. And as we continue to add more edge locations to that 38 points, your content can just be transparently available to clients that are geographically close to that location if you so choose. Any questions so far? No? Awesome. Lastly, just as importantly, you can delete an object. Generally, that's CRUD, create, etc., etc., etc. And you can delete a bucket. So over 1 trillion objects, that number is out of date. It's 835,000 at peak now. There are 2 storage models. The standard durability, which has been calculated to be 11 nines worth of durability, which is based around the fact that the data is continuously rechecksummed and stored in multiple locations and multiple shards across multiple places. If you don't require the 11 nines of durability, you can opt optionally for the reduced resilience storage, which drops it down to 4 nines and takes about 30% of the price, give or take. And that's great if you've got like a secondary copy of your data. You don't need the full 11 nines, you can shave a bit off. The costs, so the cost of the data, you're only actually paying for the amount of data that you store into S3. And that's where it becomes something that fits your model perfectly. You're not having to store or pay for a 1 terabyte drive size and only store 1 megabyte worth of data on there. If you put in a 1 megabyte file, you're paying for a 1 megabyte file to be stored. So the costs very much match your usage. You can have, you also pay for data transfer outbound from S3. You're not paying for any data transfer into Amazon. So people throw backups at Amazon all the time because they don't have to pay for that. You can have it so that the requester can optionally pay for that data transfer out if you so wish. So it's another way of transferring data if you've got large data sets and don't want to have to pay for that overhead. And the costs do differ per region. Again, that comes back to us being a high volume, low margin retailer, where it's more expensive for us, it's more expensive for everybody, where it's cheaper for everybody. Nicholas, microphone. With the button at the bottom. There we go.
With the reduced redundancy,
yes.
With the reduced redundancy, have you noticed that in practice? As in, is that independent? If you have 10,000 objects, do you lose one a year reliably?
Well, we've not actually been aware of any that we've lost.
Yeah, just a risk.
So obviously there's a lot of monitoring on that kind of stuff. So that's been operating, since about 2007. And in that time, yeah, nothing's been lost. It's merely a calculation of the likelihood. And to me, as I said, that number of nines meant nothing to me until somebody told me that, well, if you have 2 SANs under best practice campus cluster with full support, then you're looking at between 5 and 6 nines of durability of the data that you write there. So 11 nines, by comparison, is a hell of a lot more durable without having to go and buy 2 expensive SANs. Cool. You can also have lifecycle management on an S3 bucket. And up until about 3 weeks ago, that lifecycle management was basically, after this many days, delete the object. Which is nice, because if you know the policy of your data that you want it to be there for 5 years and then delete it, setting up the policy takes away the guesswork of somebody else who, if you were to do it manually after 5 years, and let's say you were to come along, Hanny, and say, right, it's my job now to delete the data. Who do I ask? The people who were here 5 years ago aren't here anymore. I think I'll just leave it there. So knowing that you can actually assign a lifecycle policy there gives you that sort of comfort that things will happen as they are. Now that's been extended about 3 weeks ago because of the Glacier launch, and when Glacier was announced, we also took the rare step of pre-announcing the integration of Glacier for archive and S3 for online live access with what's now being called S3 archive. So the lifecycle policy has been extended so that after X days, basically take that object and put it into Glacier, but leave a reference to it in S3. So that at any time you can call for that object to be restored back, or copied back actually, I should say, into S3 for access to that data for a certain number of days. So if you've got a bucket out there in a region which has got Glacier available, you could modify your lifecycle policy now and say anything that hasn't been accessed for 30 days, throw it into Glacier, and then suddenly you'll find that your data charges will drop through the floor. EBS, durable block level file system. So when EC2 first launched, it only had what was then called ephemeral or instance store local storage available. So if you shut the machine down and start it up again, you were starting from a blank disk, effectively. EBS is the persistent storage behind what is now commonly used for root file systems because it's persistent every time you shut down and start up. You can create any file system on it, it's up to you. You might want to play with ButterFS, you might want to play with ext4, as you wish. Charges are based on the size allocated. So versus S3, where you're only paying for the amount that you store, if you provision a 1 terabyte disk for your instance, then you'll be paying for a 1 terabyte of disk. You go from 1 gig to 1 terabyte at the moment. You can stripe them. You can use LVM. I've done a large number of LVM tricks over time to get larger and larger volume sizes or higher throughput. And you can now also set specific performance requirements, so IOs per second. You can also snapshot all of your volumes, as we said earlier. And if you're running a database or anything like that, it's good practice always to sync, to flush all of your data and then take a snapshot. And yes, you can use it as raw block devices for LVM, as we were saying.
Copy on writes? So
It does actually in the background, yes.
So you have one image for all your machines and then as it modifies.
So if you're taking multiple snapshots, it is actually, so you're obviously charged for those snapshots to be stored, but those snapshots are effectively deflated copies of your block volume and then differentials between each of the snapshots you would take. So it's being as fair as possible and as optimal as possible in the storage, because if it's more optimal for us, it's more optimal for the customer, everybody wins. So Glacier, as we said, low cost, durable and flexible. It's got the same security as S3. It's simple and you can leverage all the other AWS services around it. It's a great way for replacing tape libraries and robots. I know I've had tape libraries before that have annoyed me when the elastic band is broken on the picker. And then you have to go and buy the magic elastic band from the right place, and you've got a week worth of... Or you go to try and restore your old LTO1 tapes in your LTO4 drive and find that, no, it only goes back for 2 or 3 revisions of disk drive. So typical uses for Glacier. Stuff that's not accessed frequently. It's really got to be the long-term archive stuff. It's not the stuff that you're going to be reading and writing all the time. If you're going to be reading, I mean, backups generally are potentially reused or accessed within a couple of days of being made. After that, you might want just a more recent backup, not the older backups. So the stuff that's true archive is the stuff that's right for Glacier. EC2, instance sizes, basically as t-shirt sizes. So small, medium, large, extra large, double extra large, quadruple extra large with chips. It's basically set sizes of CPU and memory. There are some special purpose ones on there, including the NVIDIA CUDA capable chips as GPUs. So if you're doing any mass parallel stuff that you want to be able to do on a machine, you can fire up one of those. It's worth noting that all of the CPU and memory you get is committed to you. It's not shared or somehow burstable or anything like that. The only exception to that is the micro instance, which has got burstable CPU up to what we'd call 2 ECU, elastic compute units. But the micro is great for doing little dev jobs and things like that. Windows or Linux, you're only paying for the hour. The operating system license is included for Windows. And that micro, the pricing starts, generally I think around the world, they're about 2 cents an hour. And you can get cheaper prices if you think you're going to use it for the next year for 100% of the time or 50% of the time. There's a pricing model called reserved instances where you pay a small amount up front and your per hour price drops through the floor. And you can get discounts of up to 70% by looking at the reserved instance model. Otherwise, if you're just going to turn it on and turn it off and you don't know what you're going to be using it for, the on-demand pricing, 2 cents an hour is pretty good. It's worth also noticing that if you were to have one server for 1,000 hours, it's the same price as 1,000 servers for 1 hour. So if you've got a job that can be done in parallel, you can have that massive amount of scale instantly and then get rid of all the compute, get your answer quicker. And the last line there, obviously, as I said before, where it's cheaper for us, it's cheaper for our customers. Elastic load balancers. Now, I talked before briefly about having multiple availability zones and the ability to architect your application to take advantage of this. Elastic load balancing is, I guess, the superstar that sits in front of each of those availability zones, spans all of them, and routes your traffic appropriately. We can change the load balancers dynamically. So if your site is quite small, you'll have some small load balancers. as your site gets more traffic, or if you're doing SSL decryption offload onto the load balancing tier, it might get busier, and so Amazon puts in faster and bigger load balancers over time, and they get cycled out. And also, this is in homage to the IPv6 talk that was going to be tonight. ELB also supports IPv6. So if you wanted to get stuff up and available on IPv6, currently put an ELB in front of it, and you'll be up and running. Autoscale. And this is where it starts to get a little bit interesting. Yes, Nicholas, question.
Load balancers, HTTP only, or HTTPS only?
TCP only.
TCP only, so any service
TCP,
takes port.
any port you want, generally, I think. You'd have to check exactly which ports you want to use. But yes, it can do HTTP, HTTPS, or generic TCP. And port translation to another port if you wanted to. So there's a few tricks that you can do in the ELB layer. Autoscale ties into elastic load balancing quite neatly. This is where you get to dynamically add or remove instances on demand. So for example, if you had a service which was coming under some load, and you set up a metric to indicate, let's say it's going to be the CPU, average CPU of your web farm has hit some threshold, then you'd want to add another compute instance to that and have it register in the load balancer. Likewise, if your CPU load, for example, drops below some threshold, take one away until you've hit some minimum, obviously not zero. So Autoscale lets you do that and updates the load balancer appropriately so that you can grow and shrink. And so we've got a lot of customers who make use of that to deal with daily spikes, hourly spikes, and they're only paying for that compute as they're doing it. You got a question, Hanny?
Does it cope with
Hang on.
DOSs?
Does it cope with DOSs? DOS is an interesting thing. So one of the things is, yeah, that's actually a reasonable way to deal with DOS, is to outgrow your attacker. That's one option. You can grow if
Are there any other options?
well, you can put a limit on it. The other thing is you could actually tier through some intrusion detection system if you wanted to. So you can architect your network with multiple layers. And I've seen, in fact, on our SharePoint white paper, there's an architecture which was a SharePoint deployment, I think for the US Department of Financial Recovery or something. And they had 7 layers of their application, of which the first layer was an IDS, which was doing that kind of intelligence and dropping of packets based on what was going on. So you can do that.
But it won't drop packets at the network layer.
At the network layer, no, it shouldn't do. It should scale to handle whatever load you're getting. Because denial of service might look like legitimate traffic until you've inspected the packets to work out what's going on. Yes, Nick?
Just a comment, maybe it's worth more to your company to be open and working on launch day than it is to be denial of service at any cost.
Absolutely. I mean, you want your service to be up, and that's actually, your reputation of your organisation might rest on the fact that your service is up no matter what. If you were to release a Facebook app and go viral, how does that not look like a denial of service? Or a /dot link or something like that, which suddenly gets you vast amounts of traffic from lots of distributed points. It's actually potentially legitimate traffic. Click frenzy, thank you. Databases, so I mentioned RDS, our managed database service. Now, before I go into RDS, obviously you can start up an EC2 instance, you can install any software you want on it. You check the licensing, that's up to you to do. But you can install a database server on there, no problems. Run it, look after it, organize your backups, just as you would normally. Organize replication, as you would normally. But if you'd rather have that taken care of for you, you can use RDS, which is the Relational Database Service, which supports MySQL, Microsoft SQL Server, and Oracle. And for Oracle and SQL Server, you can bring your own license if you want, or you can use our by-the-hour licensing. We've got an in-memory key value store, which is effectively Memcache compliant on the protocol. You use a Memcache library called Elasticache, so quite useful for sticking in front of databases to do layered caching before you hit your DB. We've got a mass email sending service called Simple Email Service. Anyone here received an email from Amazon before? Yeah, every time you've ordered something. Everyone appreciate getting that email and making sure it doesn't go through spam filters and things like that. Comes down to things like reputation of the IP addresses it's being sent from. And so with SES, we send it from a specific set of IP addresses, and we do a lot of stuff to try and help people whitelist and improve their list that they're sending email to. So we do capture bounces and unsubscribes, and we put that into notification queues so you can programmatically deal with a mass number of bounces, drops, unsubscribes, etc. In your application, and iteratively increase or improve your sending list. And that's obviously just a case of parsing a disparate number of mail servers messages that come back into a programmatic way that's uniform and consistent.
Do you do anything to stop customers from sending spam from your
Yes.
high reputation IPs?
We limit, and then we will monitor your reputation. And basically, it's almost game theory. So if you send good emails and your reputation is good and you don't have a lot of bounces, the capacity that you can send through, the speed at which you can send, goes up. If you have bad reputation, it goes down. And so we kind of manage that reputation on top. There's additional things we do in there as well. We can optionally sign your outbound messages with DKIM, the Domain Keys Identity Management. And if you happen to be using our Route 53 hosted DNS, that's as easy as clicking a button, and we'll go and publish keys into your hosted DNS for you. Otherwise, you can go and take the keys and put it into your own DNS as you wish. NoSQL. Anyone here using NoSQL databases? Yeah? So we've got two, for good measure. SimpleDB was our original NoSQL database, but then this year we released DynamoDB, which is basically off the work that was done on a paper that was released a couple of years ago by Amazon employees to do performance-based NoSQL. So DynamoDB is actually what's used behind the Amazon shopping cart. Effectively what it is a service where you configure it by requesting a certain read and write throughput. So I want to read 10 requests a second, I want to write 5 requests a second. And it will provision the right amount of equipment behind a service endpoint to give you that throughput. And then when you come along and say, well, no, I'm happy with 5 writes a second, but I want 5,000 reads a second. And it will go and auto shard into multiple nodes to give you that throughput you want. And then when you turn it down again, it auto coalesces back. So it's basically taking care of that management to give you that throughput that you're after. And so, yeah, obviously with the Amazon shopping cart, we have busy parts of the year, quiet parts of the year. It's now the middle of December. It's getting to be a busy part of the year. And so we dial that up, and then come January when things start to settle down again, we can dial that down again and release some of that infrastructure and use it for other stuff. That all make sense? Yeah? Cool. Hadoop, big data. The Elastic MapReduce service is basically, it's managed Hadoop. But whereas normally if you were doing this on premise for yourself, you'd go and buy a bunch of clusters and you'd do a job and it would take maybe an hour or two, and then the cluster would be idle. Well, why have hardware sitting around that's not in use when you could just pay for that infrastructure, that compute, as you need to do it, and then free it up? Coupled with a great place to store large amounts of data sets, such as S3, with its limitless volume, then you've got everything you need to be able to do your big data analysis in the cloud. DNS, I touched on that briefly talking about SES, but DNS is our Route 53 hosted DNS service. You basically tell us to host a zone for you. We're not a DNS registrar, but if you've gone and got your domain, you can come to us and we will run the DNS service for you. That operates out of those 38 edge locations that I spoke about earlier. You're given 4 DNS names to go and take to your registrar to delegate out to, and then just add and remove any of the zones, any of the records that you want in there. CDN, CloudFront, again, 38 edge locations today, and constantly growing. Data warehousing, this was actually announced last week, I think it was, at our global conference in Vegas, is a data warehousing option called Redshift. It's quite new. In fact, I haven't had a chance yet to read through the documentation, but effectively, if you're doing anything on data warehousing, again, like Hadoop, where you've got an outlay for infrastructure to do a standard job that you might not be doing 24/7, you could free up that infrastructure and just do it on demand. And a lot more. Getting started.
If I may.
Yes, certainly. Microphone, please. Hanny, yes.
So how do you get a large amount of data
How do you get a large data in or out?
into
Into?
Amazon?
Absolutely. Well, out of is just as valid as well. There's 3 ways of putting data in and out of AWS. One is online, straight over internet. But that might clog up your internet connection if you've got a large amount of data for an unnecessary amount of time. We do accept private connection straight into the cloud. We publish a set of addresses where you can interconnect to us. And so when we launched the Australian region, we published that I think it's the Equinix SID3 facility is available to take a fibre into. You can take a 1 or 10 gig fibre or multiples thereof. Obviously, you need a tail circuit which comes all the way back to Perth for this room. But there are people who are doing that, and it's becoming cheaper all the time. The third way is the Andy Tannenbaum way. It's the hard drive in the post. Never underestimate the bandwidth of a station wagon full of tapes. So you can actually send USB or SATA disks in the post, fill it up with data, ship it in. We'll import that data and put it into either S3, Glacier, or EBS if it's within the size limits of EBS, and then send you back the disk. So basically, your storage becomes a caddy.
Can we send that to Sydney now?
Yes. Oh, no, sorry, you can't send it to Sydney yet. So data import-export isn't currently available in Sydney. But we're interested in expressions of interest from customers that would like that there. So signing up, as I said, having an account is free. In fact, if you have previously shopped on Amazon, you've already got an account, you can actually use that one, because we already know who you are because you bought stuff. That was an evil laugh, Annie. Verify your credit card and telephone number, and you're away. Now, your account, when you start up for fresh accounts, has soft limits on everything, because we don't want people signing up and suddenly ringing up massive bills and getting sticker shock, or potentially doing something nefarious. So you'll find that by default, you can do 20 virtual machines, which for a lot of people is more than enough. But if you're doing enterprise workloads, then that's going to start to be a bottleneck pretty quickly. But that's as simple as filling out a form on our website or talking to your local Amazon people, and we can up the limits. There is a guide called the Getting Started Guide with AWS, which basically does a step-by-step of what you could do to get started. And there's a bunch of stuff that you can do on AWS for free, which includes your first micro virtual machine free for the first year. So if you want to serve it, go for it. In fact, most of our products now have either got a free tier or free initial offering or something to give you a taste of it, so you can give it a spin and see if it suits what you're looking to do. Getting data in and out. I'd forgotten I had this slide in here, but this is just for you. Online, and you can IPsec. Now, talking of VPC there, this is one of the new things for enterprises called virtual private cloud. So I guess Amazon traditionally has been seen as public cloud, but obviously a lot of people like having private cloud. Virtual private cloud lets you carve out some of the resources on AWS for yourself, stick an IPsec tunnel into the middle of it, and no one else can get to it. You can use your IP addressing if you want to. In fact, we recommend that you use something that's consistent with your internal IP address topology, and effectively it's an extension of your internal network. Direct connections, as I said, through the points of interconnect or import-export service. The interesting thing, as I touched on earlier, data sent to AWS is not charged for. Data out from AWS is charged for, and as you'd expect with something that you would potentially start to buy in volume, the more you buy, the cheaper it gets. And that's pretty much true across all of the services. There is support available. We have free support through the forums to start with, and that is staffed. It's not just customers looking after each other. There are actually dedicated staff. I've sat with them in Seattle and seen them do their stuff. That's actually quite an awesome experience to see some of the things that come up. And there's the public health board dashboards and stuff like that that you can all find. But then we have developer support if you wanted an SLA on getting a response out of Amazon's support network. It's $49 a month, which is pretty cheap. But the SLA on a response for developers is 12 hours. But it's your development environment, 12 hours is probably fine. Cool. Does that all make sense to everyone? Beyond that, we've got business support, which is then becoming an interesting sum of either $100 or a percentage of how big your environment is on AWS. So if you're really small, you're probably not going to have that much of a support overhead. If you're running a massive enterprise on us, you probably are going to be a little bit more support. So that's why the support tiers up to match your usage, basically. You get a 1 hour, up to 1 hour response SLA then on your urgent priority cases, and you get access to the Trusted Advisor service, which is a service which looks at what you've deployed on Amazon and gives you recommendations of how either to save money, make it more secure, turn stuff off if you're not using it, all this kind of stuff, which is the kind of stuff that you do yourself, but basically wrapped up as a service for you. And then we have our enterprise support, which comes in at more, but then you get the SLA drop down to a 15-minute SLA, and you also get a technical account manager based in Australia. Well, obviously, if you're in Australia, not if you're overseas, then it would make any sense. We can also support third-party products through our support service. So we've got agreements with a whole bunch of people, and there's a bunch of other stuff that we know stuff about. So it's one of the things you can come to AWS for if you wanted to. Saving money, on-demand pricing. So I spoke about the pricing models before. But if you know you're going to have stuff turned on either full-time or a regular amount of a month, then the reserved instance pricing can save you a fair amount of money. And then there's the fun one, the gaming option. You can bid on the unused capacity on Amazon Web Services. So obviously, we've got a lot of compute. We have our standard pricing, and there's some of it which isn't being used all of the time. So you can put a bid in at a penny if you wanted to, and you might get your compute. But if somebody else comes along and we are out of capacity at that point, and they've bidded 2p, 2 cents, then you'll lose your 1 cent bid. So it's great for background jobs and tasks like that, which can happen at any time, but you don't want to pay full rate for. So it's an option to play with. Reduced redundancy storage, I spoke about before. If you've got a secondary copy of your data on S3, then you can use that to save some money. For high volume CloudFront, so if you're doing a lot of web traffic, and I mean a lot of web traffic, then we can actually look at some additional pricing for you. For data archive, move it into Glacier. If you understand that true archive is stuff you can leave and forget, then that's a great option to save money. Dynamo NoSQL, look at binary data types, which was a new addition into that. So it can be more efficient on wire transfer using binary types instead of character types. That's out of date. I did update some of this today, I promise you. But the slide is already out of date no matter what. So we introduced a whole heap of stuff. So Node.js, which I was supposed to say Node.js, I was typing this very quickly today between appointments. We released a Node.js. Anyone here do Node.js? Brilliant. An SDK got released last week. So you can actually use that. Elastic Beanstalk is our platform as a service that we released for Ruby. It already supports PHP and Java. It's basically instant deployment from your IDE. Our throughput metrics for Elastic Block Store got increased to 2,000 IOs per second. We introduced new instance types with more CPU. Storage gateway got updated so that you can deploy a storage gateway, and what it is, it's a virtual machine you'd run on premise. And it's basically transparently masking S3 to on-premise using local disk as temporary cached storage. So you can provision up to 32 terabytes on a LUN on-premise, but just give it 100 gig. T1 micro instances inside virtual private cloud. S3 redirects, actually James and I, you were talking about that earlier. Provision to IOPS and read replica promotion for RDS. Read replica promotion is a quite interesting thing. So if you've got a database and it's pretty busy, you've got reads and writes, selects and updates going to it, you could have a read replica, so a slave basically, send your select queries to the slave, send your update queries to the master. If you wanted to shard your data, one of the options we've got now is you can take that slave and promote it to be a new master by itself, and it would have an identical copy of that data at that point in time. And then simultaneously, you tell your application to now shard your data, use tables A through L on that one and M through Z on that one, or whatever sharding you want to take as a manual shard, and then drop the tables you're not using on each of those two masters, and then continue to grow out if you wanted to. CloudFront also now has support for price classes, so if you didn't want to serve your CloudFront CDN out of Tokyo and out of South America, because it's too expensive potentially, you can restrict them off your CDN list. Cross-object resource sharing from S3, so that you can basically have clients upload data directly to S3 instead of having to proxy it through. Cross-origin, thank you. Cross-origin cause. Billing cost allocation reports. Basically, if you've got billing for other people, if you're consulting for other people, you can tag up resources with customer ID or anything else you want. You could even tag things for development and production, and then have your bill sliced and diced as a CSV, and you'll be able to see what you're being charged for and potentially on bill for that. Redshift. Windows 2012. Anyone here played with Windows 2012 yet? Little bit? Did you find the start button? Wow.
It was awesome.
Amazing. So if you wanted to play with Windows 2012, you could fire it up on a micro and have a play with it. So as I said, the slides are probably already out of date. In fact, they definitely are out of date. There is so much coming out that generally you'll find there's something new from Amazon every day or two. We have a blog as well, which is updated pretty regularly, so you can have a read on that. There's also a load of videos being recorded pretty regularly as well. Stuff that's going on right now. So we've been doing some lunch and learn series. Basically, it's a sandwich and a chat, and we'll talk about something new. And obviously, the big thing we've been talking about that's new was 2 weeks ago. We had one here in Perth, where we were talking about the Australian region launch, where you can now, instead of having to go to Singapore or the States, you can bring this up inside Australia, which is important for government and anyone else who's got data jurisdiction concerns. You can now do this all in Australia. It was about an hour and a half each one. Lunch was provided. We had a chat. In fact, I think, who here was at the last one? We did three of you. We had like over 100 people turn up. So that was pretty good. We've been doing a load of webinars as well. So these are done live. So one of us from the team will sit in a room with no one else there, and we'll talk at a laptop for an hour. I've not done it yet myself, but the rest of the team sit on our laptops wherever we happen to be in the world, and we answer the questions of people who are watching the presentation and listening as they're asking the questions. So actually, if you had random questions about a topic that's being pulled up, jump on that and you can ask questions of the entire team. And if we don't know right then to answer your question immediately, we'll find out and get back to you. And lastly, we've got a user group for AWS, for customers to talk about the kind of stuff they're doing on AWS or problems they've been having or anything at all. It's about to have its inaugural meeting in Adelaide on Monday. It's not run by Amazon, it's completely independent. We'll get involved and help out where we can, obviously. But we like to let customers actually feel that they've got their own ability to talk amongst themselves without feeling that it's sponsored by Amazon and sort of peering over their shoulder. For the curious, things to explore, the things I'd recommend that people look at if you wanted to start playing. Virtual private cloud is the big thing for enterprise on the cloud, to be able to carve it off and give it your own IP addresses. There's no cost for defining a VPC. It's just one of those things that's a useful kind of security mechanism to put in there. In fact, you'll find that most security overlays on AWS aren't charged for. So we have what we call identity and access management, where you can set up users, either people or scripts inside your AWS account. There's no charge for any of those. There's no charge for turning on virtual multi-factor authentication, so two-factor authentication to your account. And generally, you'll find that anything that helps you delete data is also free because it helps you. CloudFormation. CloudFormation is the ability to template your environment. So if you ended up with an environment, if you think of a database server, which has got a certain size, you've got a web tier, you've got a load balancer, you've got security groups, and all of these components of your environment, you can put that into a template and launch that template as one thing, and also tear it down again as one thing. Which becomes really useful if you're then doing something like QA, and you want to give a QA engineer their own environment, which is a copy of production. Or potentially the instances might be smaller. You just change the instance type, size, and off you go, launch it. 4 hours later, tear it down. You're only paying for the environment while it's up, but you're not going to be invalidating QA Engineer 1 from QA Engineer 2 by, oh, I've changed a parameter in the database, so the application does something completely different now. So it's quite flexible like that. IAM and multi-factor authentication, as I just mentioned. That's basically it. So with that, I've got a video to show you guys about some of the stuff that one of our customers has been doing, which you probably saw a little bit of earlier. Would you like to see the video first, or do you want to do some questions? Video? Video. Right, give me a second. Let me pull this up. Here's one that someone prepared earlier. Is that on there somewhere? Is that full screened? Is that playing?
Take a few moments to learn how, in just 60 minutes, NASA can process a day's worth of new discoveries from the Mars Science Laboratory. The red plains and pink sky of Mars hint that volcanoes, meteors, and flash floods once shaped the landscape. Today, a number of robots, sent by NASA's Jet Propulsion Laboratory, explore the atmosphere and surface of Mars. These rovers are on a quest to find out whether the red planet is, or ever was, an environment able to support life. However, Giving instructions to a Mars rover is more difficult than most people realize. Unfortunately, there's no joystick controller a scientist can use to move the rover around. And even at the speed of light, it still takes between 7 and 20 minutes for a transmission to go from Earth, across space, to the rover on Mars. To make matters even more complicated, there are only short periods of time in which scientists can communicate with a rover at all. This makes for a precious window of time in which NASA JPL engineers must determine the next day's mission for the rover. Sometimes they have just a few hours to download data from the rover, then process and interpret that data in order to send new mission instructions back to Mars. When they can speed up the analysis of the data, it leaves more time for science. That's why the team uses Amazon Web Services to spin up hundreds of Intel Xeon E5 processors when they're needed. With the scale and performance of this on-demand computational cluster, NASA JPL engineers are able to drive 12 teraflops of performance for less than $40 an hour. This leaves more time to work on programming Curiosity's next steps. It also enables NASA to get greater utilization of the rover's unique capabilities. Closer to home, NASA JPL scientists also use Amazon Web Services and Intel Xeon E5 processors for other computationally intensive workloads, such as robotic articulation calculations and Arctic climate analysis, all while enabling their researchers to work more productively and cost-effectively. When the team needs more computational power to support these and many other missions, they can easily provision what they need as and when they need it. This on-demand scalability lets NASA scientists and engineers keep their focus on exploring the Earth, the solar system, and the universe beyond.
Cool. There's a bunch of those videos on a website that Intel and Amazon put together called Power of 60, where the NASA one was the one that really grabbed my attention, but there's a bunch on there if you want to have a look at more. Cool. Any questions? Yes. Ewan. Sorry, microphone. Do you want to pass it back, Penny? And turn yourself up. There we go.
When using Red 53, are we restricted to IP addresses that are inside the Amazon?
Absolutely not. No. So all of the products, generally, you can use them independently. So you might use Route 53 and nothing else in there. In fact, I was talking to a customer yesterday who basically was going to start with doing that. They just needed somewhere to have a DNS master and secondaries. In fact, we don't deal with them as separates. They're basically 4 DNS servers. In fact, 38 DNS servers because it comes from all of those edge locations. So yeah, if you just want to put DNS in there, you can point them at anything, use it for anything, just DNS. It was kind of so Route 53 has been out for about, I'd say it's just over a year, maybe 2 years. It was, I guess, one of the missing pieces of the puzzle at that stage to try and bring together what is online web services with DNS and how do you get to the thing. It's an interesting product that it also supports latency-based routing. So if you wanted to send people in Australia to the Australian region, you've got support for that in there, whereas sending people in Europe off to the Ireland region, you can do that. And there's a team behind it. Each of these products has separate teams working on them. And they've got their own roadmap of stuff that they're working on to bring out. So there's more features planned for all of these things. Jason?
So that working independently applies to CloudFront too? You don't have to use compute nodes within Amazon's cloud?
Absolutely not. You can use it for anything. You can use any web server as the origin for CloudFront. And like with everything else, there's no commitments and no contracts on this. So if you decide you want to use CloudFront and you serve 5 objects from it, and you decide, no, I'm not going to use it anymore, that's fine. You'll only be paying for the amount of traffic that you actually transfer out of CloudFront. You have full control over the TTLs on CloudFront. You can even do private signed URLs with expiration on them. So for example, my object, james.png, question mark, security token equals some cryptographic hash, expiry equals something else. I give you the URL, James, and it's going to last for the next 60 seconds or 2 seconds because I've just generated it from my application in the HTML that I'm generating. You access that, it's great. You pass the URL across the room, it's no longer valid. So yeah, you can use it from any bucket, any origin server. Anyone else? No? Excellent. Thank you very much then. I'll step then out of being AWS and let me step into plug. Like that, something. Thank you myself for coming.